B. In addition to division operator, C also provides a modular division operator. This operator returns the remainder on dividing one integer with another. So there is another modular division operator. That means which returns the remainder on dividing one integer with another. Thus the expression 10 by 2 yields 5. So we can write like 10 by 2 which results in 5, whereas 10% 2 yields to 0. Note that the modulus note that percentage, that is modulus operator, cannot be applied on float. So it can be only applied on integer, it cannot be applied on float. Also note that using percentage sign of the remainder is always same as the sign of numerator. So percentage sign of remainder is always same as the sign of numerator. Thus minus 5% 2 yields minus 1, whereas 5% minus 2 yields 1. Point C, an arithmetic instruction is often used for storing character constant in character variable. So arithmetic instruction is used for storing character constant in character variable. For example, char a b d. So a is equal to f, b is equal to g, and d is equal to plus. When we do this, ASCII values of the characters are stored in the variables. ASCII values are used to represent any characters in memory. The ASCII values of f and g are 70 and 71. So ASCII values of the characters are stored in the variable ASCII values, which are used to represent any characters in memory. So there are ASCII values assigned also. So this was point C. Now point D. Arithmetic operations can be performed on ints, floats, and chars. Thus the statement char x y int z, x is equal to a, y is equal to b, z is equal to x plus y. So arithmetic operations can be performed on ints, floats, and chars. Since the addition is performed on ASCII code values of characters and not on characters themselves, the ASCII values of A and B are 97 and 98 and hence can definitely be added. So ASCII values of A and B are 97 and 98. So addition is performed on ASCII code values of characters and not on characters themselves. Now rule E, that is the point E. No operators are assumed to be present, it must be written explicitly. In the following example, the multiplication operator after B must be explicitly written. So A is equal to C into D into B xy, that is, this is a usual arithmetic statement, and it is converted to C statement like B is equal to C into D into B into X into Y. This is C statement. So this first was usual arithmetic statement and C statement is written like this. Now point F. Unlike other high level languages, there is no operator for performing exponential operation. Thus following statements are invalid. So there is no operator involved for performing exponential operation. Thus these statements are invalid, which are as follows. So A is equal to 3 multiplied by 2. B is equal to 3 raised to 2. So these statements are invalid. If we want to do the exponential, we get it done this way. So we have to use a separate math function for this.